So one of the things when you start reading a question like this one, it starts off with the graph of y equals 1 over x. And in that moment, your brain should go, hey, that's one of the graphs that we did. And in your mind, you already have the graph with its asymptotes at y equals 0 and x equals 0 and the shape of it like this. This all comes to your mind almost instantaneously. You're like, okay, that's my graph. There's the asymptotes. Those are the key points. So you have that in your head. You might not need the graph, but that is there available for you. And then you're asking yourself, okay, this is going to be translated 3 units to the left and 2 units up. So you can imagine this going 3 to the left and 2 units up. What is the equation of the image graph? So we don't have to graph it. We could, but we don't have to graph it. All we need to do is find the equation. Now for the equation, if I'm moving 3 units to the left, that's inside the function. And the 2 units up, that's going to be outside the function. So in this case, what does inside the function look like? Inside the function is going to be x plus 3 on the bottom of your function. And then 2 units up is going to be a plus 2 afterwards. And I find with this reciprocal graph, it's the hardest to tell what's inside the function and what's not. Because like with a square root, there's like the square root sign keeps going and make sure that it keeps it inside. X cubed, you have brackets, so it's really easy to see that it's inside. But this one, I find that that x plus 3 on the bottom is a little bit harder to see what's in the inside. And so for this question, this is all you would need to do. And if this makes sense to you, great. Perfect. You got it right away. Okay? But there's going to be some questions. I think there's one coming up in the homework that in the other class a lot of students had trouble with because it's not easy to see what's inside and outside right away. And so one of the strategies you can do is show a little bit more work and use function notation to solve this. So what we're going to do to begin with is we're going to let f of x, say that was my original function was 1 over x. And in function notation, if I wanted to go 3 left and 2 up for any function, I would write it like this. The 3 left would be inside the function, and the 2 up would be outside of the function. And this would be true if f of x was x cubed, if f of x was the square root of x, if f of x was something we haven't even done yet. Function notation says whatever function you have, if I put a plus 3 inside, that moves it 3 to the left, plus 2 outside, that moves it 2 up. And then after you have it in function notation, you could switch it back to regular notation. Now, switching back to regular notation means that you understand how functions work. Now, people are really good, so this is my function. And I said, what's f of 3? What does that equal? 1 over 3. Okay? As soon as I put a number in there, you guys are amazing. Like numbers like, oh, I just put the number in for x. Feel good about that, right? And that's the key to functions. Oh, I shouldn't have chose a highlighter this early in the morning. Computer doesn't like the highlighter in the morning. So let's highlight this, pretend it's going to work. When you have a function, oh, look at that. Whatever you put in for x, that replaces the x. And so numbers are fine. But as soon as someone says, well, what would f of x plus 3 be? The rule stays the same. This says you replace the x that you had with an x plus 3. This is the key to understanding functions. And so this would equal 1 over x plus 3. And so using function notation by showing the 3 left and the 2 up, that's really easy in function notation. And now we can translate it back to explicit notation. When you have just an x, that notation is called an explicit equation. And so I can say, well, 1 over x plus f of x plus 3 is 1 over x plus 3. I'm going to underline this part in purple and this part in purple, and then I still have the plus 2 afterwards. So I'm going to make up and add an extra example here with one that's more complicated with doing it directly. Because I think a bunch of you, since we did the 1 over x graph, I think you could have got this final answer directly, right? Okay? The graph of y equals x squared minus 3 cubed plus 2x plus 5. Now, I'll try and... No idea what that graph looks like right now, right? Everybody good with not having an idea what that graph looks like? Perfect. That's your graph, and it's going to be shifted 2 to the right and 4 down. What's the new equation? And this one really is a good example of not being able to do it directly. The 4 down is actually the easy part. You just have to subtract 4 at the end. But the 2 to the right is a little bit complicated, because where do you put 2 inside the function here? And so using function notation, so if you let, and you can use f or g or whatever you want, if you let f of x equal this, in function notation, 2 to the right and 4 down would be x minus 2 inside the function and 4 down outside of the function. Function notation stays the same no matter how complicated the original one was. In function notation, inside the function, outside the function, that stays the same. Okay? You got it? Yeah, so the minus 2, because it's opposite, that's going to cause you problems, trust me. And then the minus 4, because it's exactly the same for outside of the function. Now, how do functions work? If I have f of x minus 2, that means in my original function, wherever, oh, my highlighter is working happy, here's my x, here's an x, here, oh, here's an x. It's warming up. So if you have function notation and you're now replacing that x with x minus 2, wherever you had an x originally, you now have an x minus 2. So what does that look like? Okay. Y equals. Do you sense a little bit of frustration? Y equals again. There it is twice. Really quite impressive that I made almost the identical y. This is that, wow. Okay. Yeah, okay. Y equals, so wherever we had an x, so we had an x here, I'm going to write it in blue. Now I'm going to replace that x with x minus 2. I still have this squared. I still have this minus 3. I still have this cubed plus 2. But now instead of that x, I'm replacing it with x minus 2. I would still have that 5. And this whole thing in purple is this. What do we have after the purple? We still have to put a -4. Now, we could simplify this if we wanted to, but I'm just going to leave it like this for now, just to have that idea. Okay, now this is even more complicated than the one that you're going to get in your homework, but I want you to get a sense of what function notation is. And like I said, you guys are fine as soon as it's numbers, but as soon as we start replacing other things in there, it gets a little, like your brain starts to not feel confident, right? If you wrote this one out, would you have felt confident after writing that answer out? Would you have been like, oh yeah, got it? Or you'd have been a little bit like, I really want to put numbers in different, I don't know, I'm just going to, I know I need a -2 somewhere, so I'll just put it somewhere. And that's what you do. You sort of like, I kind of know, but I'm not quite confident enough. Okay? So in math, part of what I like about math is that the rules stay the same even if you feel like you're bending them. Okay? Oh, you want to see some bending rules just early in the morning? Okay? Just because it's fun, right? Do you guys remember how to factor a difference of squares? Yeah? What would you do? You'd do x plus 3, x minus 3? Okay? Can you factor this? No. Not with your normal rules. But what happens if I pretend this is a difference of squares? And I have plus 3 and minus 3 here. What would have to be there and there? What multiplies to get x? Yeah, x to the half or a square root of x, right? And that actually works. So it's the same idea. You're just bending it to a new thing. And I don't know if we're really bending anything or switching anything around here, because this is just the rules of functions. But sometimes when you replace an x with x and something more, it feels wrong. Okay? And it's just a little bit awkward. But the idea is the same. Wherever you have your x, it gets replaced with an x minus 2. Okay. 12, 13, 14, and 15. Don't worry, I won't get this excited and off topic on math on every question. Otherwise, we will never finish the whole semester. So.